Okay, folks, here's how to correctly do all of test 2. This first one, gotta remember, Kc is equal to products over reactants of all gases and all aqueous. So that means just H2O squared over N2O. So 11.2 squared times X is equal to our Kc of 584.7. You don't need the mass of ammonium nitrate. So 584.7 divided by 11.2 squared means you have 4.66. Okay, combustion of benzene. It's a rate reaction. There is a typo here. There should be molarity per minute. It should be molarity per second. Okay. Either way, without that typo, you still should have been able to get this. 30 is the benzene. 30 over 2 equals X over 15. The only way this works, 30 divided by 2 times 15 is 225. 225. However, if you tried to turn minutes into seconds, say 225 molarity per minute, well, in 1 minute, there's 60 seconds. So if you divide by 60, you get 3.75. At best, you would be able to get C. But best you'd be able to get C if that was the case. However, this is supposed to be a so easy one. How could you get so far off? I mean, there shouldn't be that big of a rounding error, but goofed on my part either way. Days. So this should also read seconds. How many seconds would it take for this reaction to go? First order, you have a rate constant K. The key thing here, so K is 2.6 10 to the negative third. T is, we don't know, but A sub 0, we're going to assume 100%. A sub T is how much would degrade. It takes that for 63% to degrade. That must means there's 37% left. So the equation is ln 37 over 100 equals negative 2.6 times 10 to the negative third times T. Solving that. So ln 0.37 divided by negative 2.6, 10 root negative 3, get 382. So A. Now this one should not have been hard. What does a catalyst do for a reaction? The idea is this is your standard mechanism uncatalyzed. What does it do? It lowers the activation energy. The activation energy is the difference right there. Well, it lowers the activation energy, so it's harder. I mean, it takes less energy to react. It doesn't give the molecules more energy, but it lowers the energy barrier, which is the activation energy. It lowers that energy barrier that keeps it from reacting. For a given reaction of this, blah, 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 Kc is this at 298. What direction will the reaction shift if the concentration of CO2 is 0.18 and concentration is 0.015? So products of reactants, Kc equals H2CO3 over CO2. So Q is equal to 0.015 over 0.18. 0.015 divided by 0.18 is equal to Q is 0.0833. K is 0.35. So hopefully you can agree that Q is greater than K. Q is greater than K. So how do we solve that? You solve that by decreasing the amount of products and increasing the amount of reactants to make this ratio go down. It would actually shift back to reactants. Shift back to reactants. What is a reaction at equilibrium? Should have been an easy one. It's specifically when the rate of forward reaction equals the rate of reverse reaction. That is how you know it's at equilibrium. It doesn't fully stop, and the products and reactants don't have to be equal. And temperature doesn't have to stop changing. And even if temperature doesn't change, that doesn't mean it's done. Now, this one was a tricky one, 7. So, which reaction would favor products if pressure went down? So pressure goes down and temperature goes down. So when Q is negative, heat is a product. So heat on this side, when Q is heat on this side, Q is positive. When H is positive, Q is a reactant. Remember, when you add something, it shifts away. When you remove something, it shifts towards. So the decrease in temperature means it cannot be C, it cannot be D. It has to be A or B. Decrease in pressure. So an increase in pressure pushes it towards less gas. When P goes up, it goes to less gas. So when P goes down, it would be more gas. Shift towards more gas. So this was 3 gases versus 2 gases. So it's not A. 1 gas versus 2 gases. So it's B. The solid is the trick. Okay. Now, 8. What did you find rate data? What is the rate constant for this guy? So when compare experiment 1 to experiment 2, we have, I'm going to skip some steps, but 202.5, 7.5, the 2 rates equals K over K, which cancels out, 3 over 1, I want to call that M, and 5 over 5, N. Those cancel out. What happens when that 202.5 divided by 7.5 is 27. So 27 equals 3 to the M. The only way that works is if M equals 3. I compare 2 and 3. 202.5 over 202.5 equals K over K, 3 over 3 cubed, 10 over 5N. So you get 1 equals 2 to the N. Only way that works is N equals 0. So your reaction is rate equals K A cubed. So pick any reaction, D let's say the first one's easiest. 7.5 equals K times 1 cubed. 1 cubed is 1. But if I did 202.5 times 3 cubed, you get 27 divided by 202.5 by 27, you get 7.5. Answer is only D. Okay, number 9. Conversation between conversion from N2NO2 to N2O4 is modeled by a second order rate law. If the reaction is has a half-life of 55.3 hours when the concentration is 5.34 molar, was a constant, how much of the original 5.3 molar would be left after 1 day or 24 hours? So A sub 0 equals 5.34. T1/2 is 55.3 and T is 24. So I think K is equal to 1 over A sub 0 T1/2. So you start with that, say 1 over 5.34 and 55.3. Get K is equal to 0.003386. You have 1 over A sub T equals KT plus 1 over A sub 0. So our K times 24 now plus 1 over 5.34. And then we have to inverse that. You inverse that, you get 3.72. Well, it should be less than half. So definitely not this guy. It should be less than half. Less than half of it. It's less than a half-life, so less than half of it should have gone away. So really, these guys are not good answers. However, you're between this guy and this guy. However, at first, at the initial stage, it goes faster than at the later stages. So really, D is the best answer, even without doing the math. This guy, K sub P equals K sub C times R T to the delta N. The reaction is 1 plus 3 gases goes to 2. What was it? So 4 gases goes to 2 plus 1, 3 gases. So our N is -1. Delta N is -1. Saying, actually, sorry. God's sake. Forget all that. You're just finding KP. KP is CO2 times SO2 squared over CS2 times O2 cubed. So with all of our numbers, respectively means in the order that they're initially stated. So 0.223 cubed. This was not meant to be a hard one. This was not meant to be a hard one. I'm sorry if this was. So 4.52 times 6.34 squared divided by 0.125 divided by 0.2233. We get a really big number. That's 131 10 to the 5th. Now, this one is the KC to KP. I jumped the gun. We have 1 solid and 2 gases goes to 2 plus 4, 6 gases. And delta N is 4. So if KC is the given number at 298 Kelvin, what is your KP? So KC is 4.0 times 10 to the fifth. And R is 0.08206 times 298 to the fourth power. So when you multiply the product of that number is 24.5, raised to the fourth power, it's a really big number, times your KC, you get 1.43 times 10 to the 11th. Now this one was not meant to be hard. Well, it's meant to be challenging, but there's only one answer that makes sense. The hard fast rule, remember, is for every 10 degrees C, speed is times 2. For every 10 degrees up, speed comes in. So if I go from 1.3 times 10 to the negative fourth to 5.2 times 10 to the negative fifth, it's essentially going from 13 to the 5. 13 to 5 is a little bit over 13 divided by 5.2 is a little bit over 2.5 times. So we are halving the speed and halving it. We're not quite halving it the second time, but we're definitely more than halving the speed. So with that in mind, slowing down means temperature goes down. So A is going to be right out. Because it's more than halving, we at least need to lose 10 degrees. Losing 0.2 degrees does not make sense, so B is right out. Because it's more than halving, but not quite like going down to 0, negative 269 does not make sense. Really, the only answer is D that even makes sense. But let's try the math. ln K1 over K2 equals E delta H over R 1 over T2 minus 1 over T1. So ln 1.3 E negative 4 over 5.2 E negative 5 equals 27,000 over 8.314, 1 over T2 minus 1 over 298. So start with evaluating the left side, 13 divided by 5.2. Then I times my R, divide by my delta. I get a really small number. I subtract by my 1 over 298. Actually, sorry, I add. I add 1 over 298. My bad. And then I inverse. And if I hit inverse, it goes to 274.8. So you get T is 274.8. If you minus 273, it rounds up to 2 degrees. So the correct answer is 2. Uranium has a half-life of 23.5 minutes. So T1 half is 23.5 minutes. How long much of a 5,000 gram sample would be left after 6 hours? So 6 times 60. So ln 2 over 23.5 is going to give us our K, which equals 2 by 23.5, K of 0.029, we'll say 5. Now, ln A sub T over 5,000 equals negative KT. So our K times our T, which is 6 times 60 times -1. We have to do the inverse log of that answer and then multiply by my 5,000 to get my answer. And we would get your answer is 0.122 grams, which you turn that into 122 milligrams. This one, kind of ice table, but kind of not. I've given you KC. So ice table, H2 plus I2 goes to 2HI. This was actually easier than it looks once you know what you're doing. If I start with 0.803 molar of that and 0.641 of that, when equilibrium is established, you have 0.252 molar of that remaining. So minus x plus 2x. Okay, so we have right there, what's the concentration of HI that is formed? Well, 0.803 minus x is equal to 0.252, meaning x, 803 minus 0.252 is equal to, x is equal to 0.551. However, the amount of HI is equal to 2x. So that would be equal to 1.102. So the correct answer is C. Not meant to be, well, it's meant to be a little bit of a thinker, but you don't have to worry about it too hard. Now this one, meant to be easy, was incredibly harder than I meant it to be, just because people forgot. Activation energy is the difference between these two numbers. You go from here to, from reactants to products. So 301.63 minus 27.63 is 274 kilojoules. The activation at the delta H is the difference between here and here. Products minus reactants. So 104.9 minus 27.63 means it would have to absorb 77.27 kilojoules of heat. Go. Okay. Last one. Based on the following two rate law of the equation, NO2 plus CO, that what must be the first step in a two-step reaction? Now, it was kind of hard. It's kind of hard. It's a two-step reaction. A two-step reaction, step 1 and step 2 must add up to give you this. So no matter what, step 1 and step 2 must add up to give you this. But the fact that the equation is 2 NO2s means that step 1 is probably something like this. We'll just call it X. And then X plus CO goes to NOCO2 NO and X or some or NO2 again. Who knows? But the fact of the matter is, if this had NO2 and CO in the equation, I mean, if the second step was slow, then we would have everything included. But instead, CO is not included. It's zero order in CO, meaning it cannot have CO in any of it. The first step has to be slow, and it can't have CO in there anywhere. So the fact that there's two NOs means it has to be A. In fact, I went over this example in class. Okay, who was named in this chapter? Technically, Arrhenius. Arrhenius was one. Le Chatelier was another. The Haber process. I know technically I probably accepted Clausius Clapeyron. Clausius or Clapeyron. Because I often referred to Arrhenius equation in a similar fashion. So all those would have been good answers for that one, but that was probably one of the harder questions of the there that very few people filled that one in. That was the test.